Hello, everybody. It's Mr. Everett. Just want to go over this lesson on exponents. Some of you weren't there. Some of you may not have totally understood. So we'll go ahead and start simplifying exponents. And I want that. All right. So we need to know exponents are repeated multiplication. So I have my number here, which is my base. And up here is my power, or we can call it's an exponent. Okay, so I'm going to repeat this, multiply it by itself 10 times. I'm sorry, n times, not 10 times, n times. So we're going to expand in order to come up with a rule, right? Because we have, and here's a better example. So 2 to the power of 3 is not 2 times 3. It's not. It's 2 times itself 3 times. And this is expanded. So I've expanded it. This is exponential notation. This is expanded. All right, so first we're going to do it. Some of you may already know the rules, but we're going to go ahead and derive those rules. So for example, here I have 3x 3 times, which would be the same as 3x, right? I'm sorry, not x 3x, it'd be x cubed, sorry. That's the same as x cubed, or x to the power of 3 over x. Now, if you don't see anything up here, it doesn't mean nothing's there. It just means it's to the power of 1. So that's x to the power of 1. And I'll come back to why that's important. So how can I rewrite this? Well, I could say it's x over x times x times x. We'll even put over 1. These two are the same. The reason we do that is because I want you to see here that x divided by x is 1, not 0. Any number divided by itself, except for 0, is 1. So for example, 5 divided by 5 is 1. How many 5s are in 5? 1. 1,000 divided by 1,000 equals 1. So I'm looking for my 1s to cancel out. So what am I left with? Well, I'm left with x times x, which we know is x squared. So let's look at this. I have x to the power of 3 divided by x to the power of 1 gives me x squared. So we're looking for a pattern here. We're looking for a pattern. So I have x to the power of 5, which is not 5 times x, is x times itself 5 times. So x times x times x times x. 1, 2, 3, 4, 5 divided by x times x. So I'll go ahead and do it anyway. I have x times x over x times x, right? Times x times x times x, because this cancels out. All I have left is x times x times x, which we know is x to the power of 3. So x to the power of 5 divided by x to the power of 2 is equal to x to the power of 5. X to the power of 5 divided by x to the power of 2 is x to the power of 3. X to the power of 3 divided by x to the power of 1 is x to the power of 2. So we should start seeing a pattern for division. Let's do this one. So x squared times x to the power of 3. How many is that? That's 5 times. Equals x to the power of 5. So x squared times x to the power of 3 is x to the power of 5. I'm multiplying. I should see a pattern. 2, 3, 5. Let's multiply again and see if that pattern happens again. So n to the power of 3 is n times n times n. And n to the power of 5 is 5. I'm sorry. It's n times n times n times n times n 5 times. Well, how many do I have? I have 8. So n to the power of 3 times n to the power of 5 is n to the power of 8. I hope you see the pattern. When I'm multiplying, 2, 3, 5, 3, 5, 8. Okay? We're looking for a pattern. All right. So let me look at this one. have 16 to the power times w to the power of 3 divided by 8 to the power times, 16 times w to the power of 3 divided by 8 times w to the power of 2. So I'm going to take 16 over 8 times w, so multiplication, to the power of 3 over w to the power of 2. Now, I'll write this out one more time. 16 divided by 8 is 2 times w times w times w over w times w. Cancels out. I only have one left, 2w. So notice, w to the power of 3 divided by w to the power of 1. 2 is w to the power of 1. So I'm going to give you the rule. The rule says that if I have some number to the power of m divided by that same number to the power of n, then my answer is going to be m minus n. You say I'm subtracting 3 minus 2 gave me 1. 5 minus 2 gave me 3. And 3 minus 1 gave me 2. That's my rule for division. What is it for multiplication? Well, if you notice here, I had 2 plus 3 gave me 5. 2 plus 3 gave me 5. 3 plus 5 gave me 8. So I'm multiplying, I'm adding. Remember, there's a 1 here. So I have m to the power of 6 times m to the power of 1 must be m to the power of 6 plus 1, which gives me m to the power of 7. Same thing, I'm multiplying. That must be x to the power of 4 plus 5 plus 3. No need to mark out all those x's. We know because we're multiplying and I have the same base, I'm going to add 5 plus 4 plus 3, which gives me 9 plus 3 is 12. That's the rule for multiplication and division. Already done these two. What about this one? All right, I'm going to take my like terms and put them together. So I can take 6 divided by 2. I only have one x, and I have y divided by y. Well, y divided by y we know is 1, as long as y is not equal to 0. And 6 divided by 2 is 3. So I have 3x to the power of 3. Right? So here I have, this is the same as, I'm going to put my like terms together. I'm saying like terms. And x to the power of 50. Now, same base. So I'm going to subtract 50 minus 15. That's 1/2 x. Let me write that. $50 minus 15, which is 35. Now you may also see that written as, because 1/2 is the same as dividing by 2 to 35. Okay, that's a little long. Let's see what I got next. Okay, I'll do this real fast. So what we've learned, our rules for division. Now I haven't shown you this one yet, but I'll try to do that one. So I have, now this one is a little tricky. It's going to lead us to our next lesson. So some of you may have noticed is x to the power of 9 minus 11, which is x to the power of negative 2, which is right. But sometimes they don't want negative. So what I could have done is said x 8 to the power of n. H to the power of n, h to the power of 11. I could have moved my 9 down here and done h to the power of 11 minus 9, which gives me 1 over h to the power of 2. And we'll get to this later. That just means h to the power of negative 2 is the same thing as 1 over h to the positive 2. And we'll look at that in the next lesson. And real quickly, so now what this means is this whole thing gets squared. So I have to take 3 times k to the power of 5 times itself, right? So again, what are my like terms? 3 and 3. So I have 3 times 3 times k to the power 5 times k to the power 5. Well, 3 times 3 is 9. We just said that if we multiply same base, k, I have to add. I don't have to write 5k times k times k. I messed up there. Sorry this video is so long, but I don't need to write, but you can. But, so that's 1 time, right? It said do it 2 times. I'm going to end up with how many? With 10. So my final answer is 9k to the 10th. All right, that's long enough. So I hope that helps, and we'll practice some tomorrow, and we'll also move on to these negative exponents tomorrow as well. Or I'm sorry, Tuesday.